Number 4 says, at 8 a.m., 2 cars started from the same place. One traveled north at a rate of 49 miles per hour. The other went south at a rate of 56 miles per hour. At what time were the trains 420 miles apart? So, oh, sorry. I always forget that people, if someone's watching this video, they can't read the whole thing. All right. So, we're going to make our chart. Rate times time equals distance. I have 2 cars, so I'll just call it car 1 and car 2. Let's see. Car 1, what was its rate? 49. Car 2's rate was 56. How long was car 1 traveling for? X. You don't know. I hope nobody put an 8 in there because you saw 8 a.m. Remember, time of day has nothing to do with this time right here. Who cares? They could have left it any time of day. This is length of time traveled. So I don't care what time you leave at. I care how long you've been traveling for. And I don't know how long it's been traveling for. How long has car 2 been traveling for? Someone said it. I heard it. It's also X. At 8 a.m., 2 cars started from the same place. So they started at the same time. Just one went north, one went south. You multiply straight across. Once you get those 2 columns, 49x, 56x. And then what's my equation going to be this time? Who's got it? Who's got it? Go ahead, Haley.
49x plus 6x equals 400.
Perfect. There it is. Now you just do the math. Oh, what is those 2 together? 105? Is that right? Is that right? Is that what you got? Oh, good. Look at me go. I love when I get it right. That would be 4. Okay, now here's the twist with this one. This one, look at what they're asking. At what time were the trains, they should be cars instead of trains, sorry. At what time were the cars 420 miles apart? Remember what X stood for. X stands for the length of time that car 1 has been traveling for. How long has car 2 been traveling for? Also 4 hours, right? They both left at the same time. So now here is where time of day actually comes back into play. So the answer is not they will meet after 4 hours, because that's not what I asked. I asked at what time, not after how many hours. I'm saying at what time. So what's the time? The time would be 12 a.m. or p.m. p.m., right? AM and PM matter, so be careful. It would be 12 p.m. when the cars meet, because 4 hours after 8 a.m. is 12 p.m., right? So that's actually the answer to the question, not 4. See how this one had a little hidden thing there? They're asking you at what time. So the 2 cars are 420 miles apart at 12 p.m. Let's say this was another 5-point question. You got the chart perfect, that's 2 points. You wrote the equation perfect, that's 2 points. But then you gave me an answer of 4 hours. You're going to lose 1 point there because that's not the right final answer. But you have all your math right. So if you just always make sure that you are answering the question that they asked. They asked this particular time about the time, not the number of hours. Okay. Are we feeling a little bit better about distance problems, maybe? Yeah.
Do you think we could do number 11? It's kind of different than the others, slightly.
Sure, okay. So here's one where you don't know the rates. So we've done a bunch where we knew the rates. This time we don't know the rates. So let's read 11. Two planes started at the same time from the same airport and flew in opposite directions. One flew 60 miles per hour faster than the other. In 5 hours, they were 5,300 miles apart. Find the rate of each plane. So this time I'm looking for the rates. We'll make our chart. Isn't the chart so nice? It makes things so much easier to break down and sort of give you a place to start. Because I remember when I did these word problems in school and we didn't use charts and it was so confusing and nobody knew what they were doing. But the chart, like, you always know how to start. You're like, oh good, I know how to make a chart. Hooray! And then usually there's a column or two to fill in very easily. So, this time though, do I know the rate of plane 1? No. So, and I don't know the rate of plane 2. I just know that one plane flew 60 miles per hour faster than the other. Does it matter which one I call X and which one I add 60 miles to? It doesn't matter. One of them is going to be X. The other one will be 60 miles per hour faster than that. So in math, that means, what would I? Right, 60 plus X or X plus 60, either way. So there's one having a rate 60 miles per hour faster than the other. What's going to go in for time? 5, they told you, in 5 hours. Remember, there's only ever one column that you don't know. In this case, it's the rates I don't know, which means I better know the times, because you're not going to use another variable here. I already used it. So these I have to know, and I do. It's 5. And then what do I do once I know both columns? Multiply straight across. So that's going to be a 5x. Don't forget to distribute. And now I have to go back and read the problem and see if I'm going to add these together instead of equal to a total number of miles, or they may equal each other. Let's go back and read. In 5 hours, they were 5,300 miles apart. Find the rate of each plane. So what would my equation be? Go ahead.
5x plus 5x plus 600 equals 5,300.
That's it. And now I just solve. What did X stand for again? Look at your chart. What's X representing? The rate of what? Yeah, that's the rate of plane 1, which means that the rate of plane 2 must be 560. Yeah, that's it. So plane 1 went 500 miles per hour. Plane 2 went 560. And we have finished another one.